Today, we are going to take a bit of time to discuss about the interactive process communication package, which is a fairly simple package with only a couple of activities that was added in the 20.10 release of our product. However, despite its simplicity, it is very useful in taking our attended automation implementations to the next level, as it allows processes that run together on the same PC to communicate and sync up. So, as our attended automation solution grows and our users gain more processes that they can use on a daily basis, these activities are instrumental in increasing the scalability, maintainability, and modularization potential of our attended processes ecosystem. Our goal for today's session is first to get an understanding of how these activities work, so that some of you that didn't get a chance to play with them can quickly understand how to use them, then discuss a potential use case and show a basic implementation with these activities. And finally, we will try to transpose the example in a context where it will have to work side by side with other automations and showcase a scalable event capturing framework idea that leverages the IPC activities. So let's start with a very basic demo that can show us exactly how these activities would work. To do that, we will use these two empty background processes that I have prepared, named broadcaster and receiver. If you look closely into the processes, the only special dependency I used is the IPC packages dependency that you can find on the official NuGet feed for UiPath. First, let's do the easy part. The broadcaster is the activity that is used to send the messages. It is very easy to configure, as all we really have to do is set a channel and a message property. Let me show you. The channel can be a string of our choosing, and the messages sent with this activity will be retrieved using the same channel name. The message can only be a string, so whenever we need to send complex data over to our receiver, something like an array or a complex object, we can still do it if we encode all of the data in a specific format, like JSON, for example. Okay, let's finish setting up the channel, and let's also set a test message here. All right. This is a test message. Now let's move on to the receiver. This receiver activity is just as easy to set up, but it does make use of a few extra moving parts. It is a trigger, so this means that it must be used together with a trigger scope, and it will behave just like any other classic trigger, in the sense that it will start listening for incoming messages and trigger the execution of the do block inside whenever the message is retrieved. Okay, let's just add a trigger scope first. And now that we have it, let us try to also add our receiver. When we add our receiver activity, we also need to set a channel to the same string that we used in our broadcaster. All right, let's do that. We'll set a test channel name, the same one we did for our broadcaster. Okay. Now, with the latest version of the trigger scope, we can use the args object to access the properties of the received event. So we can get things like the message, the name of the receiver, and the type of the receiver, which is very useful if we have multiple types of triggers or multiple message receivers come together. This would help us tell the difference between them. So let's just start by accessing the message. Let's see how to do this. We don't want to do anything complicated. We'll just try to log the message to the output window and use the log message activity for that. So we'll use the args object to get the message. And then we'll also use another log activity to type the name of the receiver. This is going to be very useful, as I said, if we were to have multiple message received triggers here. We could tell what message receiver gave us the current message by using this property. So the trigger name is very, very important. Okay, now let's test our code. So first, we will execute the receiver process. And you will see that once we do this, the process will simply be on hold and wait until a message is received. Okay. Now, let's also execute the broadcaster process. You can see that as soon as the broadcaster is executed, the message will be sent to the receiver, and the broadcaster will stop its execution. But the receiver will continue, and it will wait for other messages. So let's just just check the receiver output. You can see here that we have the test message that we set earlier. And we also have the trigger name set correctly. Now we want to finish everything, so let's just stop our receiver too. Now that we got a basic understanding of how these activities work, let's review some useful tips and facts. First of all, if the receiver is off when the broadcaster sends a message, the broadcaster will not receive any exceptions and the execution will continue normally, but the message will simply be lost. So, using the broadcasting activity does not mean that the process it is part of needs to be executed only when the receiver is running. It can either be executed in combination with the receiver or autonomously. We get a high degree of versatility this way. Another thing is, even if a message is sent on a channel where multiple receivers are listening at the same time, all the receivers will get the message. So this also gives us an extra boost of flexibility when designing our automations. Another thing to keep in mind is that both the receiver and the broadcaster can either be foreground or background processes, but they cannot be both foreground processes at the same time, as they won't be able to run at the very same moment. When using multiple receiver triggers grouped together, it is very important to rename them all differently as to help determine where each message is from. You can remember that from the demo we did previously. Another thing to keep in mind is that these activities work for only relatively small messages, around 1 megabyte. However, this is more than enough for most use cases. And one final thing that we should all remember is that this package only allows for processes on the same machine to communicate. It will not allow for processes on different machines to keep in touch and sync up. We know how these activities work now, and we have a bit of information about them, but let's think about a real use case where they might be useful. Let's consider a scenario where a contact center agent handles customer calls throughout the day, and in a point in the process, the agent is required to place the call on hold. We would like not only for our robot to assist the agent with some of these tasks, but we would also like for it to periodically remind the agent that the call is on hold in order to make sure that the agent will not keep the customer waiting for too long. To simulate this process, we will use the dummy Acme test application, which you can see right here. This is a very useful, simple application to simulate contact center scenarios. You can see that we have this trigger call button, which we can use to simulate an incoming call, and then we can act as an agent. We can answer the call, we can put it on hold, or we can simply hang up. So we will use these functionalities in order to simulate our use case. Okay, so given this use case, what would a proper solution be? What we would have to consider is that we would need a trigger process that permanently monitors the user's activity and checks when the hold call button is pressed. Once that hold call button is pressed, the monitoring process will start another job, which will then execute the relevant process actions and then show periodic reminders that the process and the call is currently on hold. We can use the trigger process that I mentioned earlier to also capture clicks on the resume button, and using the IPC activities, we can send a message to the hold process and stop it whenever the call is resumed or is hanged up. This is the first part of our solution. This is the trigger process, which is called call center master in this case. It has a parallel activity, and inside it, it has two branches, each one containing a trigger scope. Let's just take each branch at a time and analyze it. First of all, we have this branch which will wait for the put call on hold button to be clicked. Once that happens, the do block below will be executed, which will start the hold reminder process. This is the process that will show periodic reminders to the agent, telling them that they have to resume the call at some point. On the other branch, we have the hang up event and the resume call event. We have two triggers, which whenever they pick up that their respective button was clicked, they will execute the below activities. Here we have a broadcast message activity, which will just send an exit signal to the hold reminder process, telling it, okay, the resume button or the hang up button has just been clicked. You don't need to do anything anymore. You don't need to show any other reminders. This is the hold reminder process. This is the part of the automation which will show the periodic reminders to the user. Okay, so let's see how that works. This process also has a parallel activity inside, and it has two branches. The first branch, called display reminders, let's open it, will show the reminder periodically using a call out activity. It will pause for a given amount of time, which is configurable. It will send as an input argument, and then it will show the callout once the time is passed. Afterwards, if the user clicks OK on the callout, the activity will simply repeat the entire sequence and show the callout again after a given amount of time. So this will just execute in a loop, and this part will just wait for the user to resume the process. How do we know that the user resumed the process? We don't have any click trigger activities here. Well, this is what we have the second branch of our parallel for. Here we have a message received trigger, which will wait for messages from our first workflow. Whenever a message that equals to exit is received, this part of the process will execute the code inside the then part of the if, and it will simply break closing this trigger scope, and also it will set the should exit flag to true. This way, our parallel activity will know that it's time to exit, because its exit condition is exactly this should exit flag. So I think this is pretty simple. It's not very hard to picture how these activities would work. Now, let's see our processes in action. We have our call center master process already running, and this is normal because this process, since it monitors the user activity, needs to be on at all times. What we want to do next is trigger a call. So let's just click trigger a call, and now we have an incoming call from, let's say, a made-up customer. What we need to do next is answer the call, and as soon as we do that, the put call on hold button becomes available. Once we click it, you can see that call center master instantly starts the hold reminder process. Now, if we wait for hold reminder to run for a given amount of time, I think 5 seconds in this case, you will see that the reminder pop-up, the reminder callout, is on the screen and is reminding our agent that the call needs to be resumed. Okay. If the call is hanged up, you can see that the call center master catches the event and instantly kills the hold reminder process by sending it a message telling it that it should actually stop executing itself. Okay. Now, everything is back to normal, and our call center master process is back monitoring for more put call on hold button clicks. Now, I'm sure the previous demo is easy enough to understand, but you might wonder, why wouldn't we just build this entire thing in a single process? And it's true. If we have just this process that we're trying to execute, using 2 jobs instead of 1 needlessly complicates our solution. But keep in mind that rarely will a robot be used to execute only 1 automation. As COEs grow, so does the number of attended processes, each one having maybe its own automatic start trigger. So it becomes very important for us to think about a scalable model for our attended space. What we need is a truly scalable way of handling events. One such approach involves having a dedicated monitoring process that contains all triggers and starts the appropriate job based on the user activity. Even so, as more and more processes are added, complex scenarios might arise, and we might want to disable and enable triggers dynamically based on what the process is doing at a given time. Also, since we will eventually have a very large number of triggers, managing them using trigger activities in a workflow can be cumbersome. So we might start thinking about creating our triggers dynamically and doing that starting from an Excel file, for example. So let's see how a basic implementation of this framework would look like. And let's check out this project called Trigger-Based Framework, which represents a rough idea of how such a framework would look like. Okay, first things first. I mentioned that we want to have all of our triggers managed from an Excel file. I have here in my framework an Excel file that does exactly this thing. So let me just open it so we can all see it. And you can see here that I have on each row of my file a different trigger. Now that we know this, let's try to go through each of the columns and actually try to understand the structure of this table a bit better. First, we have the name and ID columns. This can be just random strings, and they are only used to tell the triggers apart. So here you can just use any strings you want, but it's good to have them be unique values. Then we have the type column, which tells us the type of the trigger. For now, we only have 2 types, but this solution can easily be scaled up to having more than this. We have the click trigger type, which will be used to start events when a certain element is clicked in the user's interface, and the element exists trigger, which will be used to start events when a certain element appears on the screen. Then we have the status column, which can either be enabled and disabled. This is not static, however. During the execution of our framework, some disabled triggers can go enabled and vice versa. Then we have the regex filter. Okay, this is only useful for the click trigger activities, and it is used to match an element that the user clicked to the exact specific trigger. No worries about how this works. I will show you in very a short amount of time, but also keep in mind that in some cases, we might want to use a different approach. For example, we might want, instead of a regex filter, to use a set of properties, each with a corresponding value. That would also be a very good approach, but I think using regex it's a bit simpler and more suitable for this demo. Okay, then we also have the target column. This target column contains a selector that can be used by the element exists trigger to check that a certain element appeared on the screen. So whenever that element appears on the screen, a certain action will be fired off. Okay, so I hope this explains how these triggers are supposed to work. Right, but what about what do they do? That is covered by these two other columns, action and action argument. Whenever a certain trigger is fired off, the appropriate action is invoked. And obviously, our actions cannot be invoked exactly the same way every time. They will need some arguments. There needs to be some variation. And that variation is given to us by this action argument column. So each one of these actions is a different workflow in our framework. And the action argument is the argument for that workflow. Right now, we have things like run parallel process. This is an action that starts another job on the current machine. We also have the stop process, which stops a job running on the current machine. And the action argument in this instance is going to be the name of the process that needs to be started or stopped. Okay, so now let's go back to our use case and see how exactly it applies to this table. For our use case, we will first need a trigger that actually checks when our hold call button is pressed. This trigger will be enabled by default. And then if the trigger is fired off, we want the run parallel process workflow to start another job. And the name of that job is going to be stored in the action argument. You can see that this trigger that I'm talking about is actually the first row of our table. So we have this regex filter that matches the selector of the hold call button, and we have the action run parallel process, which will actually start the hold reminder job. Okay. Secondly, what we need is a trigger that checks whenever either the hang up button or the hold call button is pressed. This is done by the second trigger in this file, and you can see that this is disabled by default. This is because we want this trigger to start listening for events only after the put :hold button has been clicked. After this trigger is fired off, however, what we want to do is we want to send a stop process message to the hold reminder job. And this is why we have an action called stop process, and the action argument is hold reminder process. Okay, I hope that makes sense. Now that we understand how our triggers are stored, let's have a look at our trigger-based framework. This is the centralized process that will listen to all of the user activity. You can see that the initial part of this process is quite simple, but trust me, once we go down deep enough, you will see that it's not as simple as it looks. First, we have this init all settings activity, which creates a config dictionary and reads the data table, the trigger data table that I just showed you. So this table is read, and then it is saved as a variable, which you can see right here in the triggers data table, right? And this variable will be passed on to the rest of our execution. The monitor user activity does most of the work. So let's exactly see how this activity looks like. You can already see that it is much more complex, but no worries, I will explain how everything works. This activity contains a parallel activity with two branches. Let's just focus on the first branch for now. Here we have a trigger scope, which you can see has two different triggers. It has a mouse trigger, which will fire off our actions as soon as any element is clicked in the UI by the user, and the message receive trigger that will be fired off whenever a message is sent to this process by one of the other processes running at the same time. Let's just try to focus on the mouse event triggers first. So we have this switch here in our code, which will invoke this piece of code whenever the mouse trigger is invoked. We use the trigger name that I mentioned earlier, if you remember. Okay, good. So let's see how this piece of code functions. As I mentioned before, this mouse trigger will invoke our do block whenever the user clicks on any element in the UI. So instead of having one click trigger for every event, for every UI action, we just have a universal one that then we will have to match to one of the triggers in our table. So you can see our table here. Right, I'll go back to it in a bit. Right, so let's assume that the user clicked on an event or on a UI element in the page. Okay, what we need to do first is we need to check if that UI element is valid. We do this using the target node property. This represents our UI element. First, we need to check if it is valid using the code below, and then we need to check that its selector is valid as well. Once we determine that, okay, our target is indeed a valid UI element, what we need to do is use the regex filters that we added in our table and now that are in the triggers DT variable that I showed you earlier, and try to match any of them to the UI element that just has been clicked by our user. And we do this with this piece of invoke code. You can obviously just use a for each to go through all of the rows in the table and see if the regex filter matches the UI element selector. But I feel like if you use this type of approach with a very large number of triggers, imagine that you would have 60 or 100 elements in this table instead of just 4, as I do now, that piece of for each code will take a bit longer than a invoke code activity. So this is why I opted for this approach. Right. This will return to us the row that satisfies that has a regex filter that satisfies the current UI element that has been clicked. Once that element has been clicked, what we will do is we will execute its action. And how does this work? It's actually very, very simple. This is a different workflow that simply uses the action property. So you see the property that you have in the G column to invoke a specific workflow in our framework. And actually, you can see that all of our actions are in this folder right here in the framework. So the robot will just try to find the workflow with that very same name in the actions folder and invoke it. And then also pass on a lot of very useful information, like the row that has just triggered this event. So the trigger row, it will pass on the entire table and a few other flags that are somewhat important. Right. So this is good news because if you want to add another behavior, or if somebody would want to add another behavior to my framework, all they have to do is just add another workflow here. So it's very easy to scale up. Good. Now, let us try to focus on the other trigger that we have in our trigger scope. This is the message receive trigger. This will fire up whenever one of the other processes sends us a message. And this will be handled in our switch in the message receiver triggers case. So let's look at that for a second. You can see here that I have a process message workflow that will simply parse and execute all of the messages coming in from other workflows. Let's have a closer look. All right. So just before I start explaining this code, please keep in mind that a message can contain multiple actions, and an action can be of 3 types. It can be an enable action, a disable action, and a stop action. My messages will have this structure, so there will be a very simple JSON string, and each action will have its type specified, and then a list of trigger IDs. So for example, if I get an enable action, it will tell me, okay, just go ahead and enable the triggers with this ID. So the triggers that I have in my framework will be set to enabled. Okay, then the disabled one works in the same way. I get a bunch of IDs that my code is to disable. Okay, remember that I have a list of actions that need to be processed. So to process all of them, I will just use the for each activity. I will just process them one by one, and depending on the type of action, I will execute the appropriate piece of code. In case I get an enable action from my other process, then what I need to do is I need to modify the triggers data table using this piece of reusable code. This is very simple. It just uses a for each to loop through all of the rows in my data table and enable or disable the appropriate ones. So I won't go into detail of how that works. The disable action works very, very similarly to this, but the stop action is a bit different. When the stop action is sent from another process, this stop process flag is set to true. Once that happens, the entire process, the entire trigger framework stops. That's very easy to do, actually. If I go back to my monitor user activity, you can see that the condition for stopping everything here is the stop process. So it is very easy to simply stop everything that we're executing here using this flag. So in case one of the processes wants to tell our framework to shut down, this is the way to go. Okay, I hope this makes sense, and I hope this explains in somewhat higher degree of detail what the first branch of our parallel does. Let's try to focus on the second two. Now, hopefully, the first branch is clear, and it's easy to understand what it does. Let's shift our attention to the second one. This branch is dedicated towards executing all our element exist triggers. And even if it looks a bit different from the first one, it actually functions in a very, very similar way. What we do is we take our triggers data table and we simply filter every row that has an element exist trigger. So we just keep the ones that have an element exist trigger, right? Then what we do is we use them in a parallel for each. And for every element exist trigger, we will execute an element exist activity in a loop. And we will keep executing it until the correct element appears on the screen. So until the element with this target appears on the screen. Once that happens, the loop will stop executing and the invoke action will be triggered. The same invoke action that we had in our mouse trigger branch. So it's the same thing, really. Okay. Now, another thing that you need to keep in mind is that our triggers can be enabled and disabled at any time. So if that happens, our reset monitoring flag will be set to true. This happens in the execute action workflow, actually. And once that flag is set to true, our parallel for each will stop its execution and it will be re-triggered by this main do while loop. This is because as soon as the triggers have been either disabled or enabled, this means that our parallel for each needs to be updated with the new triggers and new activities need to be executed. New element exist activities need to be fired up in a loop. So we need to reset everything. So this will tell our parallel for each, okay, it's time for you to stop, and everything will go back from the beginning. The filtering of the data table will happen again, and the parallel for each will be executed once more. Okay, so that's how the entire framework works. You can see that it's more a conceptual framework at this point. It still needs a bit of way to go before it can actually be used in production, but hopefully this outlines the principles necessary to build a scalable framework for attended automation. Right, so hopefully we understand how the trigger-based framework works. But what about our use case? For that, we will have to use this hold reminder process in order to show the call out telling our agent that the call is on hold. If you remember, the hold reminder process name is the one used in our data table, in our triggers Excel. So you can see that this is the very process that needs to be started and stopped based on the triggers that are fired up in our framework. Okay, so let's see how this works. You will see that this is very, very similar to the version of the hold process we used in the simple demo, with only one important difference. We said that we want to dynamically turn triggers on and off, and we have this update trigger workflow that does exactly that. The way it works is we just pass an array of IDs of triggers that need to be disabled and an array of IDs of triggers that need to be enabled, and the channel, which is always going to be trigger-based framework, basically. And we send our framework this message. I want you to enable this trigger with this ID, and I want you to disable this trigger with this ID. We do this because as soon as this hold reminder process is executed, it means that the hold reminder button is clicked. So we need to stop listening for the hold call button, and we need to start waiting for the resume or for the stop call button to be clicked. Okay. Now, once we do this, once we enable and disable the appropriate triggers, we need to start actually showing our callout. And this happens in this run parallel actions workflow. And you can see that this is very, very similar to the version that I showed you before. It has the same display reminders framework that displays the callout from time to time, and it has a trigger scope which will receive the hold reminder messages. So this is where our stop process message will end up. And this message will be handled in this do block. And as soon as our process sees, okay, I got a stop message, I need to stop, the call resumed flag is set to true, and the stop trigger monitoring activity here, which is a break, is invoked. This will stop this entire trigger scope, and the flag call resumed equals true will stop the execution of this main run parallel activity. Okay. So other than this, the display reminder is just as in the last version of our hold reminder process. So I won't go over it again. Hopefully, we have a good idea of how everything works here. Right, so let's just see how this runs in practice. We'll start our trigger-based framework because this is what will monitor all of our activities. And now let's just fake a call and then answer it. Now, as soon as we click on the put call on hold button, you will notice that our trigger framework will invoke the hold reminder process. Once that is invoked, you will wait a bit of time, and then you will see the callout appearing on the screen. Right, so if the callout appears on the screen, we can just either resume the call or hang up in order for our trigger-based framework to pick up this event and tell our hold reminder job to stop. So I click the button. Now you see the trigger-based framework already sent a stop signal to hold reminder, and that process just stopped instantly. Right, let's just do it one more time. Again, I will trigger a fake call. I will answer it. And as soon as I click put call on hold, you will see the hold reminder process starting again. And I will repeat the exact same steps as before. Right, the reminder appears. This time I'll just click OK here, and I will resume the call. You see again the hold reminder process stopped, and my trigger-based framework is ready to capture another event. Okay, so that's about it with the demo. I hope you found this topic interesting, and I'm sure that by now you see the true power of the IPC activities package. I'm aware that the framework I showed might be a bit too complex to explain in detail during this short presentation, but if you're interested in learning more about it, or if you want to talk about other attended automation framework ideas, please reach out to me on the forum and we'll pick up the conversation from there. Thank you very much, and hope you have a nice rest of the day. Thank you.